In this movie, I'm going to talk about models and diagrams and explain something of the difference between them. I'm going to start by giving some of the reasons why we model systems, and then explain what we mean by a model. I'll contrast modeling tools with drawing tools, and explain how diagrams are views of some aspect of a model. Finally, I'll list the different types of diagram in UML which are classified as either structural or behavioral. Let's start with why we model software systems before we build them. Modern software systems are typically large and complex. Not all are. If you're building a simple database system with a couple of screens and tables, you won't gain much benefit from modeling it. However, the reality of most commercial systems development is that it serves the needs of large, complex organizations, and it also operates in the context of other systems that it has to integrate with. Modeling also allows architects and developers to visualize chosen aspects of the entire system, to reason about those aspects of the system, to consider alternative options and to evaluate risks associated with the system and its software, and to communicate designs to other stakeholders, now and in the future. It's important to remember that the map is not the territory. Models are not the same as the things they represent. UML models aren't programs. They're abstractions of some features of a system that will be automated. In particular, a model is quicker and easier to build than the entire system. If it allows you to test important assumptions without having to build the system, then that has a value. A model can be used in simulations so that you can learn more about the system it represents and how it will perform. A model isn't necessarily static. It can evolve and grow as we learn more about the system. We can choose what details to include in the model. It doesn't have to be everything. Remember, it's an abstraction. And a model can represent real or imaginary things in any domain. And that was a key point. A model is an abstraction. You shouldn't expect it to be the same as the thing it represents. UML defines a model as follows. A model captures a view of a physical system. It's an abstraction of the physical system with a certain purpose. This purpose determines what's to be included in the model and what is irrelevant. Thus, the model completely describes those aspects of the physical system that are relevant to the purpose of the model at the appropriate level of detail. In UML, a model contains data about all the elements of the model. They aren't just lines and characters in a drawing. It holds data about the relationships between the different things in the model. It may contain a set of predefined viewpoints that can be applied to the data in order to visualize it in diagrams. It contains diagrams that are views of the data, and those diagrams may be generated automatically in some cases. And it contains data about the geometry of the diagrams, the layout on the page. In UML, a diagram is a view onto an underlying model, in the same way as a graph is a view of underlying data in a spreadsheet, for example. If you change something in the model, that change will be reflected in all the diagrams that element appears in. For example, if you change the name of a class, that change will be reflected in all the diagrams that show that class, object instances of that class, lifelines based on that class, and so on. If you draw a diagram in a drawing tool, all you have is a static drawing of some aspects of your system. If you create a diagram in a modeling tool, then that diagram is based on the underlying data and will change dynamically to reflect the data. Different diagrams also show different views of the same underlying system model, in the same way as an architect may produce a model of a building in a computer-aided drawing tool, and can then prepare different diagrams for different purposes, for the customer, for the town planners, for the electricians, for the plumbers, and so on. Here's a diagram drawn in PowerPoint, a tool much loved by consultants. It's just a drawing with no data behind it. Here's a drawing in a modeling tool, which has been copied and pasted into PowerPoint. If we focus on the class device here, then if we look in the model, we can access data that describes that class device. We can access data that describes the features of the class, in particular its attributes, which are shown here. We can search through the model to find all references to the word device, which will show us other aspects of the system that involve that concept. We can see other views that tell us about the relationships of device with other elements of the system, including those it's linked to and the diagrams that it appears in, which may lead us to a different diagram that also shows the class device in a different context. I said that diagrams are views into the model that show different aspects of the model. UML distinguishes at a high level between structural and behavioral diagrams. The structural diagrams are these: object, class, component, deployment, package, and composite structure. They all show static structural aspects of the system being modeled. The behavioral diagrams show the aspects of the system that reflect behaviors that are executed, usually in response to occurrences of events. They are use case, sequence, communication, interaction overview, timing, state machine, and activity diagrams. We don't cover interaction overview or timing diagrams in this course, and we only use package diagrams a little in organising the model. All the rest are included. In the next movie, we'll see the modelling tool that I'll be using to create these different types of diagrams for the course.